everyone. I hope you are doing well. So today I'm going to explain the honors project for geometry, which consists of 3 parts. So make sure you're taking a look at the due dates. And the first thing we're going to do is we're going to verify what is a tessellation. Okay, so a lot of it is going to be about investigation. And what is a tessellation? It's a tiling of regular polygons in 2 dimensions. Okay, can be 3 dimension or n number of dimensions. It's called a tessellation. And the breaking up, here you can see some examples. And it is a breaking up of self-intersecting polygons into simple polygons, also called tessellations. And here we can see examples using squares. We can also see triangles, or even other types of polygons. Okay, and there are exactly 3 regular tessellations composed of regular polygons symmetrically tiling the plane. So you can see here several examples, right? You can use squares, you can use different types of polygons, hexagons. You can see the other options, right? You can use polygons with triangles, and these are all the types. Okay, so tessellations of the plane by 2 or more convex regular polygons such that the same polygon in the same order surround each polygon vertex are called semi-regular tessellations, or sometimes Archimedean tessellations. Okay, so here we have all the examples. Okay, what is a tessellation? How is it gonna look like? So let's take a look at our assignments. So the first part, it says you're gonna do an investigation on your own. Okay, so you're gonna investigate what is a tessellation and how are transformation used to create a tessellation. Okay, so we're gonna be using the types of transformations, which are rigid transformation, reflection, rotation, and translation, which I already explained before, and explained you guys that you were going to do this for your project. Then the second part, which regular polygons tessellate. So you're going to investigate which regular polygons tessellate. Remember, regular polygons have the same side length and the same angle measurements. If you don't remember, go ahead and investigate which ones are the regular polygons. And then question number 3, consider your answer to question 2. Why do these regular polygons tessellate while other regular polygons do not? Okay, so some of them are going to tessellate, some of them do not. So include a discussion of the interior angles, which is very important in your response. Also include an example of a regular polygon that would not tessellate and explain why it would not. Okay, so all this part is investigation just. And then the fourth problem says, using your geometry software, create a regular tessellation. You may use color patterns to make the tessellation more visually interesting. Make a screenshot of your tessellation and paste it in this assignment. Okay, and in the space provided below, you're going to write a detailed explanation of the steps you follow to create your tessellation. A model, worksheet, and response have been provided for you if you choose to tessellate the same regular polygon as the example provided. You must use different transformations from those model used in the model. Okay, so this is the first part. Now let's take a look at the second part of your project, 7.02. Now on this one, you're going to use your software. You're going to sketch now a non-regular polygon. Same thing, you're going to be using transformation. You're going to tessellate your polygon, and you're going to copy and paste it, a detailed description of how you did it, and you're going to take a screenshot of your construction there. Okay, and then the third part, which is 7.03, let's take a look at what is this one. So Maurice Cornelis Escher was a graphic artist who lived from 1898 to 1972. Throughout his career, he developed a passion for creating tessellations of recognizable figures. He used a number of techniques to accomplish this task. Okay, so for this part of the project, you're gonna do investigation. You're gonna investigate the techniques that MC Escher used to create his intricate design, and then you're gonna use your geometry software. You're gonna apply one of Escher's techniques to create your own tessellation, and you can use color for your design or anything you want for it to uh, be pretty and maybe have a differentiation in it. Okay, so make sure you create it and then you copy it in and paste it. You can take a snip, you can take a picture, screenshot, whatever works for you, and you're going to explain the transformation. Make sure, please, you read carefully. That you have to explain the transformation you use in your own words. Okay, copy and paste your tessellation here. Okay, and you can use whichever program you want. So today I'm going to be explaining GeoGebra. Let's do this one. And that's the program that we have been using so far in class. So let's start. So I'm using GeoGebra geometry. Remember, if you want to use your axis, I'm going to show you how to do it. Show grid, make your grid lines, or show axis. I'm not going to do it right now. So I'm just going to show you how to use the different transformations, okay, so you can create your own tessellation. So first I'm going to do one with a square. Okay, so I'm going to create a square here. So I'm going to go to the bottom. You can see all the options, bottom left, and I'm going to create a regular polygon. So I'm going to create a square now. So I'm going to do A and B, right? And I'm going to choose 4 vertices, 4 sides. Okay, so I already created it. It's a regular one. It has 4 equal sides and 4 equal measurements. So what I'm going to do is, in this case, I'm going to move it up, down, left, or right. So for that, I'm going to use a transformation, right? And which one is the one that moves right, left, up, or right? It's going to be, here you have it, translate by a vector. Okay, so look what I'm going to do. It says the options on the bottom. Select object to translate, then a vector. So I'm going to select my square. I'm going to select my vector from A to B, and then you guys see that it moved to the left. Then I'm going to do the same thing. I'm going to repeat this. Select it, select my vector from D to A, now down, and now it appears on the bottom, right? Then I'm going to do translations here. I'm going to select this one, and then I'm going to move it to the right from A to B, and I can keep doing this, right? I'm just showing you the different polygons you can use, the different options in GeoGebra, the translation, the rotation or reflection that you can use. So whatever works for you, remember, first you have to investigate as part of your project, and you can keep going, right? This one is a translation up, left, down, or right, right? And I can be continuing doing this. Select it, and then I can move it to the left from B to A. That's going to be my vector. Okay, so remember to use translate by a vector. Okay, and then you have to create your arrows vector from one point to which other point. So that's with the square. I'm going to create one with using regular polygon. I'm going to create an equilateral, a triangle. So I'm going to select my points from E to F. In vertices, I'm creating a triangle, so it's going to be 3 vertices. There you go. And then go zoom out a little bit. Okay, so now what am I going to do now? In this case, I'm going to use rotation. So it is an equilateral. Each one of the angles in a triangle are equal, in this case an equilateral 60 degrees, right? Because it's an equilateral, all the sides are equal, right? And each angle is 60 degrees because some of the interior angles of a triangle is 180. So which one of them is 60? So I'm going to use rotate, okay? This case, around a point, I'm going to select it. And it says select object to rotate in center point, then enter angle. So I'm going to select my triangle, select E, and I'm going to do a 60-degree angle. And look what happens. It created a tessellation, right? So I'm going to do the same thing all over again. Rotate, select it, then select the point of rotation. I'm going to select F, and then 60 degrees. And now it created on the bottom. And I'm going to keep repeating this, right? I'm going to select it. Then the point of rotation, I'm going to select G. Then change it to 60 degrees. And there you go. And you can keep going, right? Creating your tessellation there. In this case, I use a rotation around a point. Okay. And then I'm going to show you how to do it with an hexagon. Now let's do regular polygon. So select 2 points and enter the number of vertices. Okay, so I'm going to do this one here. And then I'm going to select 6. It's going to be an hexagon. And there you go. Let me zoom out. And now I'm going to use a reflection. Okay, so remember using the different types of transformation to create my tessellation. You're going to go to reflect about a line, this third option. It says select object to reflect, then line of reflection. I'm going to select my hexagon. The line of reflection is going to be LK. And look what happens, right? So it's the same thing. Select my hexagon. The line of reflection is going to be now HI. And there you go. And it's going to keep repeating that figure. And do the same thing. Reflect above the line. Select my hexagon. Now I'm going to select my line of reflection KJ. And there you go. And it's going to keep repeating that all over again. So remember, I'm giving you the tools, right? The explanation. So you have to do it on your own. Do your own investigation. And here we use translation by a vector, okay, for the square. Rotate around a point for the triangle, the equilateral, and reflect about our line for the hexagon, okay? And now these are regular polygons, right? So now, let me just erase everything. Now I'm going to create one. I'm not going to erase this part. Now, I'm going to move here to the bottom so I can erase my constructions there. Okay, so now I'm going to show you how to do it with a non-regular polygon, okay? So, the first thing I'm going to do is I'm going to create just a polygon. I'm going to create just a triangle. It doesn't matter. I'm not going to create a regular one, so I'm going to just one that has different side measurements and it's clean. There you go. And look what I'm going to do. I'm going to erase. I'm going to click. Let's go back. And what I'm going to do is I'm going to select, okay, my triangle, okay, and I'm going to erase, okay. There you go. So I click on it, I click move, select it, and then just erase, delete. And I just need these points because I'm going to create an irregular polygon. So after that, you're going to do midpoints. So what I'm going to do is I'm going to go down, down to construct. There you go, construct, it's here. Midpoint or center, and I click on it. And it says select 2 points, a segment, circle, or conic. So I'm going to select PN. It's going to create a midpoint for me. There you go. Then I'm going to select N, O, creating a midpoint, which are the ones in gray, and then P, O. And there you go. It created midpoints for me. Okay. Then the next step, I'm going to just create one point. So I'm going to go to point here on the top on basic tools. And I'm going to create one point in between PQ. Okay. So it doesn't matter where it is. I'm just going to have it there. Okay. And then once you do that, okay, you're going to go down to, go down, you're going to go to reflect, I'm sorry, rotate around a point, and then you're going to select here the point, and then your center, and then 180 degrees. And there you go. I already created T prime, which is a copy. Okay, you're going to do the same for the rest. And look, let me see, I'm going to do the same thing. I'm going to go back. I'm going to repeat this steps. You're going to go to point. I'm going to add a point from N to R. There it is. Okay. Then I'm going to go down to transformations. Rotate around a point. I'm going to select U, which is the point I created. And then I'm going to select my midpoint, R. And a 180 degrees. Because remember, it should be on that straight line. And there you go. I created U prime. And then the same thing. I'm going to create my point from N to S. Here it is. Point V, and then I'm gonna scroll down to transform, rotate around a point, I'm gonna select V, the midpoint of that side, and then 180 degrees. And there you go. Okay, you see it created V and V prime. Now, look what I'm going to do. I'm gonna go to move, basic tools, and look what happens if I move. Let's create our, I just want to show you, look. I went to move, and if I move T, T prime also moves. It's the one that I just created with a reflection, a rotation, I'm sorry, 180 degrees. The same thing with U and U prime, and then V and V prime, they move because they were created in a reflection of 180 degrees. There you go. Okay? I just wanted to show you that. And then you're going to join your points at Polygon. It doesn't have to be the exact one. Oops, there you go. Polygon, select all your points. So you have to join all of them. There you go. And there you go. I just created my figure. Okay, and then you can like move it differently if you want to. I mean, I can move it this way. I can move this point over there. So you can play with your polygon. Just make sure you select move. Make sure you're selecting it. There you go. So I'm just moving it. And look how it moves. There you go. Okay. And what am I going to do next? What I'm going to do. I already have my irregular polygon. And I mean, you can create your own figure. Look. I can move mine over there. Look. Create it as you want. And then what I'm going to do, once you have this, you can create your own transformations. For example, here, I can rotate, I can translate, I can reflect. For example, I can do this one, rotate, I select it, to this point. And you can play with it. And there you go. I, what I did is I rotated 180 degrees. Okay. Sorry, my cursor is kind of slow. So that's what you're going to be doing. You're going to use the rotate around a point option. And let me do it again. So you're going to select it, rotate around a point. Okay, so you're going to select the object to rotate all of it, right? And then you can rotate it around a midpoint. In this case, this one, 180 degrees. And there you go. What is happening is a tessellation, right? And I'm using rotator, rotating around a point. And you can keep repeating this. Okay, so I use rotator around a point. I use the midpoints, which are the ones in gray. Okay, and a 180-degree rotation. And I can be repeating this as many times as I want. So that's the end. Remember to please make sure you take a look at the due dates, the three parts of the honors project. And here I use transformations, translation, rotation, and reflection, okay, for regular polygons and irregular polygons. So if you have any questions, please make sure you reach out. Thank you. Have a wonderful day.